So in the earlier classes, I have explained about the plastic analysis section, which comprised of finding the shear factor and finding the collapse load and UP value for certain beams. Now here in this class, we will take up the connections. So there are mainly in steel design, we deal with the two types of connections, bolted and welded connections. So here, bolted connections, we can refer to page numbers 73, 74, 75, etc. of the IS 800 2007. Now I will discuss about how to design a simple bolted connection as well as a simple bolted eccentric connection, and what are the total provisions that are required, equations we are going to use, how to find the design strength of a joint or efficiency of a joint, all those things. So normally bolts will be of different grades. Here there are mainly two types of bolts. One is the common bolts, that is black bolts, grade 4.6, whose strength is FUB. Ultimate tensile strength of the bolt is 400 Newton per mm square for black bolts. And another type of bolt is the friction bolts, high strength friction bolts. So they work on the principle of friction, whereas these black bolts they work under shear and bearing material. So plates normally if you don't give, we can take the strength of plate as 410 Newton per mm square. There is a grade of steel, you can say. Now in this problem, we are going to find the strength of the joint. This type of joint is called as lap joint. So in case of lap joint, there will be two plates. So this is one plate, this is another plate. Of course, here I have taken same thickness 10 mm, and width of the plate is 60 mm. This is the plan, this is the cross section. These two plates are connected by lap joint by using 16 mm diameter black bolts. M16 means the diameter of the bolts is 60 mm, and there are 5 number of bolts. So the bolts are arranged in this fashion. The distance between the bolts, center to center distance between the bolts is 40 mm, which is called as the pitch of the bolt. Because the force is acting like this, tension force or whatever force is there, it will be acting like this. So these two, the purpose of this connection is to transfer the load from one member to another member. This is one member, this is another member. If you want to transfer the load from one member to another member, through the connection the transfer of the load takes place. Normally the case in the pitch value is taken as 2.5 times B, that is the minimum pitch. Minimum pitch as per the code. If you refer to the pages 70, 74, 75 of the code, you will get all those specifications. In this case, since it is D is 16 mm here, so you can take minimum pitch as 2.5 times 16, that is 40 mm. So we are taking 40 mm, or it can be 50 mm also. So normally to reduce the length of the connection, it is better to have the pitch as the minimum, that is 2.5 times D, and this is called as the end distance. End distance. This end distance is normally taken as 1.5 times D naught, where D naught is the diameter of the hole. So diameter of the bolt hole. So the diameter of the bolt hole will be more than the diameter of the bolt. So as per the code, it is given in the page number 73. He has given in table 19. Table 19 he has given, that is page 73. He has given the clearance for the depending on the diameter of the bolt. For 16 mm diameter bolt, the clearance is 2 mm. So that means D naught will be 18. 16 plus 2 18. So 1.5 times 18. You can take it as 27 mm. So you can round it up to 30 mm. So 30 mm is the end distance, 40 mm is the pitch. Since there are 5 bolts here, so the end distance is 30, then it's 40, 40, 40, 40, then this is 30. So this becomes the length of the connection. You can take this as the length of the connection. This is the length of the connection. plus 30, 220 mm is the total length from this gate to this gate. So this is how the correction is defined. Now, in this problem, he has given the details of the correction. He has asked you to find the strength of the joint. So this type of joint is called as lap joint because one member is lapping over the other member. So here, what we have to do is, so the strength of a lap joint is calculated like this. Then strength of lap joint, it is the least of. There are three criteria. It is the least of. Number one, the strength of total number of strength of bolts. Number two, the strength of plate in yielding. Strength of plate in yielding. And number three, the third criteria is the strength of plate in rupture. So the plate may fail by yielding or it may fail by rupture. The thing is, for yielding we are going to take the gross area of the plate which is given by AG, whereas for rupture we are going to take the net area of the plate AN. So here the strength of bolts means if there are 5 bolts here, 5 into strength of 1 bolt. So that gives the strength of total number of bolts. If there are 10 bolts, we have to multiply that by 10. So among these three, whichever least is there, that is the strength of the lap joint. Now we have to calculate all these three. So let me take the first one. So this I will take as P1, P2, P3. So we have to find out all the three. So out of the three, whichever is least minimum, that is the strength of the lap joint. Now first I will find out P1, so that is strength of bolt. In the case of lap joint, the strength of bolt is calculated by two criteria. One is by shear criteria, another one is by bearing criteria. So you have two criteria here. Strength of bolt in single shear. Here the shear plane is only one here. Which is the shear plane? So I can this is the shear. You can see this is the shear plane because due to this tension force, this joint may shear off like this. So that is why it is called as the shear plane. So since there is only one shear plane, it is called as strength of bolt in single shear. So this value can be calculated. Strength of bolt in single shear can be calculated. So it is actually denoted by VDSB. So it is given in page 75 of the code. You can refer page 75. There is an equation. So VDSB is equal to, you can write down the equation by using the code VNSB by gamma MB. VNSB by gamma MB. You can read the notations in the code book. So VDSB is the strength of the bolt in single shear. So now there is a formula to find VNSB. It is given there. So VNSB is equal to FU by root 3. Vn, everything is available in the code. You need not know the any formula. FU by root 3 into, you have two terms in the brackets, NN ANB plus NS ASB. NN ANB plus NS ASB. So everything is explained in the code. So in the case of single shear, what happens? This is only one shear plane. The NS value will be 0 and NN value will be 1. And this ANB is the net area. So you can calculate ANB using one formula. That formula is, so this NN becomes 1 here into 0.78 times the total area of the board, that is 5 by 4 into d square, that is 16 square, 16 around diameter, and this becomes 0. So this is the expression for VNSB. Here we can put for FU, we can put 410. FU is the 400 because FU is the strength of the bolt, and there is we are calculating for the bolt. So FUB, actually this becomes FUB by root 3. So 400 by root 3 to 0.78 into y by 4 into 16 square. If you simplify this term, you will be getting 0.78 into pi is equal to divided by 4 is equal to into 16 square, that is 256 is equal to into 400 divided by root 3. So we are going to get the value as 36.22 kilonewton. Of course, this is that you are getting 36,217.9. 36,217.9 newtons. Actually, this will be newtons because this is in newton per mm square and this area is in mm square. Mm square and mm square will get cancelled, you get this one. So I can convert this into kilonewton. I can take roughly as 36.22 kilonewton. That is VNSP. Now therefore VDSP is equal to VNSP divided by gamma MB. Gamma MB is the value 1.25. Better you remember this. Otherwise, you have to refer the table 5 given in page 30 of the course. So better you remember this table 5, page 30 of the code. This value is available. So therefore, this is 36.22 divided by 1.25. This value is VDSP for the 6 diameter blackboard. So 36.22 divided by 1.25 is 28.98. You can take it as 28.98 kilonewton. So this is the strength of M16 bolt in single shear. Now the other criteria is bearing criteria. So you have to calculate the strength of bolt in bearing. So in the case of blackboards or common boards, so there will be two types of strengths. One is bearing criteria, another is single shear criteria. Of course, when you go for butt joint, you will be having double shear. In the case of lap joint, it is only one plane will be there. That is why it is single shear. Now for this also, you have the formula in page 75. How to calculate the strength of bolt in bearing. The formula is given like this. So it is given as VDPB. You can see in that page only 75 only. VDPB is equal to VNPB by gamma MB. So you need not remember any formula. It is directly available. So VNPB divided by gamma MB. In this case also gamma MB is 1.25. This value is 1.25. And to find VNPB, you have a formula given. It is 2.5 times KB dt FU. 2.5 times KB into D into P into FU. So here this KB is calculated based on so many criteria. KB is the least of, once again, it is the minimum of, there are 4 criteria to find out KB. So it is the least of E by 3D0, P by 3D0 minus 0.25. E by 3D0, this is one criteria. P by 3D0 minus 0.25. So then the third value is FUB by FU, and the fourth value is 1. FUB by FU, and the fourth value is 1. So out of these 4, whichever is least, that is taken as the K value. Now let us calculate this. E here is, this is the value of E. N distance is the value of E, 30 mm. In this problem it is given as 30 mm. 30 divided by 3 into 18. D naught is 18. D is 16. D naught is diameter of the bolt hole. We have to add 2 mm clearance for that, for 18. Then P pitch is here 40 mm. Pitch is 40. Distance from center to center of the bolt is 40. Divided by, once again, is 3 into 18 minus 0.25. Then the third value is FUB in the design tensile strength of the bolt divided by F2 is design strength of the tensile strength of the plate, that is 410, and last value is 1. Now among these four, so 30 divided by 3 into 18, so the value is, so 30 divided by 54, it is 0.555 or 0.556 you can take, and this value is 40 divided by 54 minus 0.25, which is 0.49. Third value is 400 by 410. 400 divided by 410 is 0.976. 0.9756, and fourth value is 1. So please note that among these four, the least value is the second value. So therefore, KB we have to take 0.49 for the given problem. Once you get the value of KB, substitute here. So therefore, VNPB is equal to 2.59, 0.49 into D is the diameter of the bolt, that is 16 mm, into T is the thickness of the thinner plate. Thickness of the thinner plate, of course, here both the plates have the same thickness, 10 mm, so it becomes 10. Into Fu, please note Fu is the tensile strength of the plate, which you have to take it as 410. Please note that when you are calculating the strength of forces here, so this FUB value we are taking, whereas when we are calculating the strength of plate in bearing, we are taking Fu of the plate. Now this value we will be getting in newtons, so then later on we can convert it to kilonewtons. Now let us find out this value. 2.5 into 0.49 into 16 into 10 into 410. So this comes out to be 80,360. So 80,360 Newton means it is 86.36 kilonewtons per divided by 1000. So therefore I need VDPB. Therefore VDPB is the design strength in bearing for this case. So which is VNPB divided by gamma MB, that is 86.36 divided by 1.25. Gamma MB is 1.25. So you can calculate that. So you will be getting the value as 64.09 kilonewton. So 64.09 kilonewton is the strength of the bolt in bearing, whereas 29.98 is the strength of the bolt in shear, single shear. So among these two, the minimum value is 28.98. Therefore, I can write this as design strength of bolt, design strength of one bolt, that is 16 mm dia bolt. Least of these two is 28.98 kilonewton. Now in this given problem, there are 5 such bolts. There are 5 number of bolts of 16 mm diameter. So design strength of 5 bolts, or I can write it as strength of connection. Connection means that is 5 volts. Design strength of 5 volts will be 5 times this. 5 times, if there are 10 volts, you have to multiply by 10. That's all. So you have 5 into 28.98. So which is we are going to get it as 144.9. 144.9 kilonewton. This is the value we are going to get for the strength of 5 volts. Now the second criteria is we have to find out the strength of plate. So this is P1 value. This value is P1. Next, second we have to find out strength of plate in yielding. Strength of plate in yielding is computed based on the gross section of the plate, which we can get the formula in the same code, page 32 of the code, IS 800. You can get the value, we can get the formula for the strength of plate in yielding. Now let us calculate that. The second value, strength of plate in yielding. strength of plate in yielding. Second value, strength of plate in yielding. This is computed using the formula which is given before in page number 32. So tension members. In the design of tension members, we are going to use this formula TDG. That formula is available in 32. TDG is equal to ADFY by gamma MO. You can refer the code ADFY by gamma MO. Here, AD is the cross-sectional area of the plate. So cross-sectional area is calculated like this. Width of the plate is 60 mm, thickness of the plate is 10 mm. So this AD is given by width of the plate into thickness of the plate. So that is the cross sectional area. So here it is 60 into 10, 60 mm into 10 mm, 600 mm square is the value of AD here, and Fy value, unless it is given for Fe 410 dead steel, Fy useless value is 250 Newton per mm square. This is standard value. You can assume gamma MO is 1.1. Please note the difference between gamma MB and gamma MO. Once again, this is available in the same table 5 of page 30 in the code. So gamma MO, material safety factor, so it is 1.1. Now, substitute these things here, we are going to get the strength of the plate in yielding. So AD is 600, Fy is 250, divided by 1.1. This value will be in newtons. Please note that the value will be in newtons. So if we can convert it into kilonewtons by dividing by 1000. So 600 into 250, 600 into 250 divided by 1.1 will come to 136, 363 Newton, or it is 136.36 kilonewton. 136.36. So this is the value of the strength of the plate in cross section yielding. Okay. Next, third one. So this is the value of P2 now. According to our system, this is P2 value. Third value is strength of plate in rupture. Strength of plate in rupture, which considers the net sectional area AN. So that AN we have to calculate now. Net area of the section we have to calculate. So that is given by. So net area, the formula is given by PDN is equal to in the same page. In the same page 32, the formula is available. So TDN is equal to for the plate. He has given TDN is equal to design strength of plate 0.9 AN Fe by gamma M1. 0.9 AN Fu by gamma M1. Please note the difference here. Here Fy is used in gross variability with respect to gross yielding. Fy is used. If you are calculating with respect to rupture, head section rupture, then you are using Fu. So here AN is the net area. Net area, how to get the net area I will tell you. So your total width is 60 here. In that 60, you have to deduct the diameter of the board over here. So in this width, you have one board. You take this width, you have one board here. Diameter is 16. Diameter of the hole is 18. So you have to deduct 18 from this 16. That becomes the width now. 60 minus 18 is the width now. Into thickness won't change into 10. So it becomes 42 into 10, that is 420 millimeters square. This is the net area. So to get the net area in the width, from the total width, you have to deduct the that is the diameter of the board hole. Here of course only one row of board is there. Suppose if you have two rows of boards, then one more row of board will be there here. Then you have to deduct 2 times 18. Instead of here 18, it becomes 2 into 18. So then it is 60 minus 2 into 18, that is 36 into 10. Like that we have to take. So since there is only one row of board here, so only 18 you have to deduct, 420 we got. So Fu value, as you know from the data, it is 410. Fu value is 410 for the plate, Newton per mm square. Then gamma m1 once again, it is 1.25. It is obtained from once again the same table. So all these gamma values they are obtained from table 5 of page 30 of the code. So safety factors, partial safety factors we are going to get. So here, after substituting these values, you can get the value of TDN. So substitute here and get the value of TDN. The TDN itself is the third value, that is T3 value which I have mentioned. So let us calculate that and then finalize the strength of the joint. Strength of the joint is least value of P1, P2, P3. So P1 we got 144.9, P2 we got 136.36. Now let us see what is the value of P3. P3 is nothing but TDN. TDN is equal to 0.9 into AN is 420 millimeter square into Fu is 410 divided by 1.25 is gamma m1. Once again, this is also in newtons. You can convert them into kilonewton. So 0.9 into 420 into 410 is equal to divided by 1.25. So you are getting 123,984 Newton, or we can write as 123.98 kilonewton. 123.98 kilonewton. So this is the third value P3. Now therefore, as already told, the strength of the joint, lap joint, P1 lap joint is the least of P1, P2, P3. So strength of lap joint is the minimum of P1, P2, P3. So among these three, 144.9, 136.36 and 123.98, the least is P3, that is, therefore it is 123.98 kilometers. So this is how we have to compute the strength of a lap joint with voltage connection. So if there are two bolts, bolt lines, then when you are taking this gain value, we have to deduct 2 times that diameter of the hole from the width in the calculation of gain. And the speed and end distances, they are already given here. So the specification is end distance is 1.5 times V naught minimum and pitch is minimum 2.5 times D. That much you can provide. Even if they don't give, you can provide that, then you can calculate. So in the case of single shear, there will be only one shear plane. In the case of lap joint, always you will be having one shear plane here when two plates are connected. Whereas in the case of butt joint, it will be subjected to double shear. So in the case of common black bolts, we have to find the strength of the bolt, design strength of the bolt from two criteria. One is by shear, another one is by bearing. So all the equations are available in the code in the page numbers whatever I have given, 73, 74, 75. You can refer, find out the strength of bolt in both shear and bearing. Take the least value as the bolt value or the design strength of bolt and multiply that value by the number of bolts to get the strength of the 5 bolts. So that is one criteria. Second criteria is strength of plate. You have to calculate one by yielding. When you are taking yielding criteria, you have to take AG and Fy divided by gamma MO. So AG is equal to thickness of the plate. And when you are calculating the strength of plate in rupture, next section rupture, you have to take the next sectional area and the ultimate strength. So ultimate strength is 410, the yield strength is 250. So based on the gamma M1 is 1.25, gamma MO is 1.1. So those things if you remember, it is easy to quickly you can calculate. And finally, after getting all the three values, the least value gives the strength of the joint.